Hello guys, myself Manoj Sharma. Welcome to Technosage. So in this video, let's talk about the time complexity. Time complexity is very important topic if you want to write an optimized solution that will take less time to accomplish a particular task, or you want to just prepare for interviews, or if you are preparing for your semester exams also, or directly or indirectly you're writing a program, the time complexity is something that you should never avoid. Before we jump on to time complexity, let's first understand what algorithm is all about. So algorithm is basically the steps that we perform to accomplish a particular task. A task could be anything. A task could be to find out the factorial, to find out the sum of 10 numbers, to fetch a cup of coffee, to solve a particular problem that you encounter in your day-to-day life. Algorithm can be anything, any solution. So it's just the steps to perform or accomplish a task. It is basically not implementation. Implementation is the program that you write. It is not the implementation, it's just the steps. So there are multiple ways in which you can implement those steps. So the implementation of the step is basically the code you write. So there can be many implementations. That means there could be many ways in order to accomplish a particular task. Let's suppose you want to find out the sum of 10 numbers. You can use a while loop, you can use a for loop. That depends upon your coding standards. So there can be many algorithms to accomplish a same task, and there can be many implementation of a same algorithm. Correct? So we understood that algorithm is basically the steps to perform some task. Okay, now move on. So now let's move to the time complexity. So what is time complexity? It is the number of steps involved to run an algorithm. Number of steps to run an algorithm. In terms of the definition, it is the amount of time taken by an algorithm to run as a function of the input size. Now there is one important line that says that time complexity is function of input size. Now when we said the time complexity is the function of input, what does this means? Now imagine you want to figure out, or you want to write a function that will calculate the sum of n numbers. So the input size would be n. N could be 5, n could be 10, n could be 1000, anything, n could be anything. So the input size is basically n. So we want to figure out, or we want to write the function that will calculate the sum of n numbers. So what would be our steps? The steps involved would be, first we will initialize sum to 0. I will write it in Java. You can choose any programming language. The time complexity doesn't depends upon the programming language you choose, but depends upon the logic you write. So we have initialized the sum as 0. That means initially the sum would be 0. Now we will write a for loop. Int I is equals to 1, I less than is equals to n, and I plus plus, because we want to figure out the sum of n numbers. And here inside the loop, sum is equals to sum plus I. And at the last, we will return the sum. So now you can see there are three particular statements. Statement number 1, the initialization of the sum to 0. Statement number 2 is the calculation of the sum. And statement number 3 is the return of the sum that we have calculated through this function. So how many steps are basically involved in this? The statements are just 3, but the steps, if I write it over here, is, so 2 steps are fixed. That means for statement number 1 and statement number 3, this will execute only one time. So 2 is always constant. 2 steps are always constant. Let's suppose the number is 5. That means we want to figure out the sum of 5 numbers. So 2 plus 5. Why I'm saying is 5? Because there is a loop. If you see here, there is a loop that will run 5 times. For 5, it will run 1 plus 2 plus 3 plus 4 plus 5. If n is 10, 2 plus 10. Obviously 2 is constant, and it will run 10 times because of this loop, for loop. If n is 1000, it will be 2 plus 1000. And if the n is n, it will be 2 plus n. Since you know that here the 2 is always constant, so the algorithm depends upon the input size. So in other words, we can say that this particular algorithm depends upon the input size, and the time taken for this particular function to run is called as time complexity. That means time complexity is basically the function of the input size. So time complexity is equals to the function of input size. More the input data, the bigger the loop would be. or the number of steps will increase. Now let's talk about the big O notation. So what is big O notation? Big O notation basically compares the time complexities of different algorithms in a hardware independent manner. As we know that time complexity means the number of steps involved to accomplish a particular algorithm, big O notation compares different algorithms in a hardware independent manner. Let's suppose you have a particular task. A task can be accomplished by various steps. One step is suggested by algorithm 1, another step would be suggested by algorithm 2, then another would be algorithm 3. So big O notation compares time complexities of different algorithms in a hardware independent manner, and it will say you that whether it's a optimized solution, a best solution, or a worst solution. A good approach is one that will take less amount of time in order to accomplish a particular task, and a bad will take much time, more time. Let's suppose the task is to add sugar to tea. Here is your tea, you just wanted to add some sugar. So what could be the possible steps to accomplish this particular task? The steps would be, I'm writing the possible steps. For you, the steps could be different also, depending upon the type of tea you have. So I'll write that first we can fetch the sugar bowl. Second, I want to get a spoon. Third, I'll take scoop of sugar, which is like a scoop of spoonful of sugar. Then fourth would be, I will pour that sugar from spoon to tea. Correct? Fifth would be, I'll repeat 3 and 4 step until desired sugar. So let's suppose a person want 1 teaspoon of sugar. So I'll fetch the sugar bowl. I'll get the spoon, scoop full of sugar. I will pour it in the particular tea. And then again, I'll ask whether you want it more. I'll repeat the third and the fourth until the desired sugar level is reached. That means if you want 3 tablespoons of sugar, I'll repeat 3 and 4 3 times. So for this algorithm, I can write 2 things. First is the number of sugar cubes or sugar spoon, whatever, and here is the step. Let's suppose for 1 single spoon of sugar, I will have 4 steps. 1, 2, 3, 4. For 2 spoon, I'll have 6 steps. How? 1, 2, 3, 4. Then again 3 and 4. 1, 2, 3, 4, 5, 6. For 3, I'll have 1, 2, 3, 4. Then 5, 6. Then 7, 8. So total 8 steps. Then for number of sugar is 4, I can have 10 steps. For n number of sugars, how many steps? 2n plus 2. That means to pour n number of sugar, I need 2n plus 2 steps. So as this n grows, the number of steps will also grow, obviously. Because see, in this case, n was 2, number of steps was 6. N was 4, the number of steps were 10. So since the number of sugar is getting increased, the steps are also getting increased. So this 2 into n is constant, and this plus 2 is also constant. They don't factor into the time complexity because for each and every step, these 2 factors will always be constant, 2 plus 2 and this plus 2. So the time complexity of this total approach depends upon this n. So that means the time complexity would be O of n, which is the linear time complexity. Plotted in the graph, it will be something like this. Like this. For each of the input data, these steps are also growing. So this will be the linear time complexity of O of n, which is denoted by O of n. I'll clear the screen. So there are various time complexities defined by big O notation. First being O of 1, which is the constant time complexity, which is the best time complexity. We will learn in depth about these, but just I'm listing here all the time complexities as defined by the big O notation. Next one is O of log n, which is the logarithmic time complexity. Then we have O of n, which is linear time complexity, which we have discussed just now. Then we have O log n time complexity, which is n log star n complexity. And then we have n square, which is the quadratic time complexity. So here the list goes from best to worst, where best is the constant time complexity and the worst is the quadratic time complexity. We will learn about these time complexities in detail. Now let's practically see what time complexities are all about. First, we will discuss about O of 1, that is the constant time complexity. Constant time complexity means that the calculation doesn't depend upon the input size. Input size could be anything. The time complexity will never depend upon the input size. Let's consider an example that you have an array of n elements. The element size is n, or the array size is n, and you want to find out the element at a particular index. So here the index is 0, here index is 1, here index is 2, here index is 3. Let's suppose the elements are A, B, C, D. The function is to figure out the element number 1, the element at index 1. So irrespective of this element size, that means the array could be of size 4, the array could be of size 1000, the array could be of size 10,000, and so on and so forth. But if you want to figure out the element at index 1, that is, let's suppose this is array at 1, the number of steps involved will always be 1. For element size 1, these steps would be 1. For element size 5, these steps would be 1. For elements size 10,000, these steps would be 1. So whatever be the size of input, the steps will always be constant, that is 1. So that is the reason why the time complexity is always constant, irrespective of the input size. I'll clear up the screen. So now let's talk about O of n, that is the linear time complexity. We'll see with a simple example. Let's suppose we have an array. This is the array of n elements, and we want to figure out a number num from this particular array. How we can do is, we can use a for loop that will start from index 0 till the index length minus 1, and then we have to check that whether if the number at that particular index, let's say n of I, is equals to the number. If it is true, then obviously return that particular statement as true, else will return the particular statement as false. So we have to loop through this entire array. Function could return true after reading the first element itself, and the worst case scenario is that it could return false after reading all the n elements. That means the number will not be found in this particular array. This could be the worst case scenario. So since there is a loop involved, the loop will run till your desired number is found from this particular array. If you calculate the worst case scenario in which my full array is read, that is the reason why we denote is as linear time complexity. That means with the increase of this particular input size, the steps involved will also get increased. If let's suppose the size is 5, the loop will run 5 in case of the worst case scenario. If the n is, let's suppose 1000, the loop will run 1000 times in the worst case scenario, where what is the worst case scenario? That after reading all the array, the element still is not found. So that is the reason we denoted it with O of n, and we say as the linear time complexity. And how can we figure out that whether a program is a linear time complexity or not? It depends upon the loop you're using. If you're using a single loop, this is just a hack basically. If you're using a single loop, it could be a linear time complexity. This is just a hack. If you're using a single loop, it's a linear time complexity. If you're using more than one loop, then again, it is not a linear time complexity. It depends upon the number of loops you're using in your algorithm. So now we will discuss about the quadratic time equation, that is O of n square. We'll see an example. Let's suppose we have an array with elements A, B, C, D, and since you can see there are no duplicates in this particular array, it should return as false. And if let's suppose we have another array A, B, C, A. This should return as true since this contains duplicate A 2 times. So our function is just to calculate the duplicate, whether a particular input array is containing duplicates or not. So how you will figure out whether a particular array contains a duplicate or not? Let's suppose you have an array of n elements, 0 and n, correct? So now what you will do, you will first loop through 0 to n minus 1. And then what you will do, you will again loop. That means this element should be compared with rest of the elements, but not with its own self. And then this next element should be compared with the first element, with the next elements, but not with its own self. And then another one will take. So this particular element should compare with this, with next element, but not with its own self. So what we will do inside this particular for loop, that means for 0th element, we need to compare with all the other elements. So then again we need to put a for loop that will run from 0 to n minus 1, correct? So for element at 0th index should be compared with all the other elements of the same array. Similarly, for the element at first index should be compared with all the other elements of the same array. But the condition is that it should not be compared with its own index, because if in case it gets compared with its own index, it will return as true, because in this case, if A is compared with A, it will return true. So what we will write, we will put a if condition saying that element at this index and element at this index should not be equal. Let's say this is I and this loop is running on j. So I should not equals to j. This should be the first case. And the second case would be that element at the ith location should be equal to element at the jth location, correct? Element at the, if I show it here, element at the ith position should be equal to element at the jth or any other position. Here jth could be any other position from 0 to n minus 1 excluding its own index. If you compare element at the ith index and element at the jth index excluding I and j to be equal, then you will be able to figure out whether your array contains duplicate or not. And since this involves two loops, as we have seen that one single loop, in the worst case scenario, the entire loop will finish and you won't be able to get the desired result. So in this case, the worst case scenario would be that I'm reading the entire array and I'm not getting the value as true, I'm getting the value as false. So what it would be, this will also run from 0 to n, and this will also run from 0 to n, and how much time? This n times. So if I is running n times, j will run n into n times. So in worst case scenario, the time complexity would be O of n square, right? So in layman terms, if your program is having two loops, just consider it that it could be possibly a O of n square. That is a quadratic time complexity it can have. Now let's see the exponential time complexity, which is denoted by 2 to the power n. It represents the function whose performance double for every element in the input. Now in order to understand the time complexity of 2 to the power n, we'll take an example of Fibonacci series. So what is basically Fibonacci series? First I'll write the Fibonacci series over here. So Fibonacci series is in which each element is the sum of the previous two elements. So now let's suppose we have the element number 3, which is basically the sum of 1 plus 2. If we see the element number 8, which is the sum of 5 and 3. So each element in the Fibonacci series is basically the sum of the previous two elements. So Fibonacci series starts with 1. The next element 1 is 1 plus 0, that is 1, then 2, 1 plus 1, 2, and so on. So mathematically, the sequence of Fibonacci number is defined as the Fibonacci sequence of n minus 1 plus Fibonacci series or sequence of n minus 2, where If the Fibonacci series of 0, it should be 0, and Fibonacci series of 1 is equals to 1. Now, Fibonacci series of 1 means the first element, 0 means there is no element, so obviously the Fibonacci series would be 0. And for Fibonacci series of n, that means, like, let's suppose you want to see the Fibonacci series of 2, it is Fibonacci series of n minus 1, that is this one, and Fibonacci series of n minus 2, that is this one. So this is the mathematical formula. Now we will frame this formula into our program, and then we will see how we can achieve the 2 to the power n time complexity. Let's assume you have been given a number n and you need to figure out the nth Fibonacci number such that, let's suppose n is 2, the output should be 1. And if let's suppose the n is 9, the output should be 34. Let's suppose the n is 3, then how we'll calculate the output? Let's suppose 1, 1, 2, 3, 5, 8 and so on. This is the nth level Fibonacci series, and you want to figure out the third number. Third number is 0, 1, 2 and 3. So third number is 2. So output should be 2. So you need to figure out this output. Output number 2. Mathematical formula we have seen that Fibonacci sequence of Fn is equals to Fibonacci series Fn minus 1 plus Fibonacci series of Fn minus 2. So we will use this particular formula here. We'll write a function for Fibonacci. Let's suppose it is represented by f and it will accept the n, the input n, such that it should return the nth element. So what would be the nth element? The nth element would be return Fibonacci of n minus 1 plus Fibonacci of n minus 2, right? But this will run every time. So what would be the terminating condition? The terminating condition would be that if the number n is less than equals to 1, you just return this number. Return n. If the number is less than equals to n, return the number, else return this number. So what will happen? This will go into recursion. So here a recursive call will be started up. So for every element in the input, recursive calculation of Fibonacci series. Since function recursively calls itself twice for each of the input number, while the number is less than or equals to 1. If the number is not less than equals to 1, it will keep on calling this. If we reach this n less than equals to 1, the loop will stop, your function will stop, and you get the desired output. Now let's see the practical approach of our function, of our Fibonacci series function. Now let's suppose if we are providing n to be 5, that means the number is 5 we are providing to our function. So we know that Fibonacci series Fn is equals to Fibonacci series Fn minus 1 plus Fibonacci series of Fn minus 2. So for Fibonacci series 5, it will recursively call two functions, that is F4 and F3. The F3 will call again F3 and F2. And this F3 will call again F2 and F1. This F3 will again call F2 and F1, and this 2 will call just F0 and F1. So this F2 will call F1 and F0, and this F2 will have another call F0 and F1. So in this way the whole program will be executed, in which multiple calls will be made. The multiple recursive call would be made in order to fetch the Fibonacci series for the fifth element or the nth element. So here we see that for every element in the input, the recursive calculation is happening. That is the reason why the time complexity is reaching 2 to the power n here. Now let's talk about the logarithmic time complexity, that is denoted by O of log n. So what is logarithmic time complexity? It is basically similar to the linear time complexity that we have already discussed, except for the fact that the runtime does not depend upon the input size. So in log n, the runtime doesn't depend upon the input size that you provide, but it depends upon half of the input size. So in case when the input size decreases on each of the iteration on each or step, it is said to be that the logarithmic time complexity is achieved by your algorithm. So remember, in each of the iteration, in each of the loop, or in each of the step, if your input size is getting decreased, you should assume that logarithmic time complexity is achieved by your algorithm or your program. So now let's understand the log n time complexity with a simple example. Consider you have an array of n elements. N elements means the length of the array should be equals to n, and there will be a number called num which we want to find out in this array. So our basic algorithm or the program would be to find out whether this array contains this particular number or not, and it should return true or false. If the number is present in this array, it should return true. If the array is not present, if the number is not present in the array, it should return as false. So there are multiple approaches to do the same program, but we want to achieve this log n, and we know that log n can be achieved when our input size is decreased on each iteration. So how we can find this number into this array? We, instead of searching for that number in each of the section of an array, it is better to search for the number in a particular section where the probability of getting the number is high. Now let's suppose if I split this array into half, where the starting index would be start and the ending index would be end. So there will be this middle term which would be start plus end by 2, right? So if let's suppose this number is greater than the middle element, so what it would be? The number would be obviously be in this particular section. So now my major task would be to find out the number into this section alone and not in this section. So this will reduce unnecessary searching for this number in this particular section. Since I know that the number is greater than the middle element, so obviously my number will be in this particular section on the right side. Now let's suppose my number is less than the middle element. So obviously I can assume that in this case, my number will be in the left section. Now again, if the number is reached, now again I will split this into half, and now this time the end will be here. Let's suppose I'm considering this condition where number is less than middle element. I'll again split this particular section into half. I'll shift the end because I no need to search the array, no need to search the number into this array. Now I will shift the end position here, and again I will find the new middle element, and again I will figure out through the middle element that whether my number is less than or greater than. Now let's suppose my number is less than middle element. Again it will search in this particular section only and not in this section. And in this particular iteration, what is happening is every time I am reducing the input size. Since I am splitting the input size, you can see first I was searching for n elements in this n element array. Now I have reduced to half. I am searching only in this particular section. Then again I am splitting into half. I am searching in this particular section until my desired number is figured out, until my desired number is found in this particular array. Because at the last there will be just one single section of or the element of the array that will be compared with number, and that would be equal to that number. If it is equals, then it will return true. If it is not equal, then it will return false. That means my number is not present in this, or this array doesn't contain my number. So now how we can solve this particular program that we have discussed in order to achieve this log n time complexity? So initialize the start as 0, because you know that initially the starting index would be 0. This is by default. And the end index will be the size of the array. So the size of the array is, I'll write size of array. Size of the array would be the length of the array basically. So now since we know the start index and the end index of the initial array, we need to loop it. We'll write a while loop. What it will do, it will check that the start index should be less than or equals to the end index. Now why this condition? This is the stopping condition. Now let's suppose your array is in this section, and again you are splitting into half again. So the start will be shifting over here, and this would be the end index. And let's suppose you are not getting the number itself. At that particular point, what will happen? The start and end index would be same. So this will be our terminating condition. That means the start index should always be less than or equals to end index. If this is achieved, what we will need to do, we'll need to figure out the middle element. So the middle element would be this start plus end divided by 2. This middle element calculation will work fine in case of the even number of elements, but in case of the odd number of elements, where if you see 5 divided by 2 is something called 2.5. So this 2.5 is not an index in a real array. So we need to add the start index also, so that this should work fine. The middle element calculation work fine in case of even or odd number of elements. In both the cases it should work fine. Now what we are doing is we are comparing this particular number that we want to find out in this array with the middle element that we have already found out. If it is greater, it should be searching over here, and in that case the start will be shifted to the middle element plus 1. If it is greater than, then the end should be shifted. If the middle element is greater than the number that we are trying to find, then this end number should be shifted and it should be middle element minus 1. So after finding the middle element, we need to compare that if your particular number is less than the middle element, let's suppose. So what end would be? End would be the middle element minus 1, obviously, because this end will be shifted over here, and this will be the new array that we are searching. Else, if the number you are trying to figure out is greater than the middle element, then what it will be? The start index. This is the start index. The start index would be middle element plus 1, because in this case, in this particular case, what will happen is this start index will shift over here, right? It's just the shifting of the start and the end index based upon the calculation or the comparison with the middle element. So if neither of this condition is satisfied, that means we figure out the number, and the number will return as true, that the number is found. Otherwise the number is not found, will return as false. So I'll just clear the screen and we will revisit it. So let me reiterate what we learned here. We have an array of n elements which have a start index and an end index, and we have split this array with the middle element as start plus end divided by 2 plus start in order to satisfy the array size to be even or odd. In both the cases it should work fine, the middle element calculation. And then we are trying to figure out this num value. Now if suppose the comparison factor would be if suppose this number is greater than this middle element, then array should be here. So we need not to focus this section. In that particular case, the start index will be shifted over here. So in this case, the start would be middle element plus 1, because it will shift over here, and end index will remain the same. If the number is less than the middle element, then obviously the number will be in this particular section of the array. So in that case, the end will be shifted here. So and in that case would be middle element minus 1, and start will remain the same. Now again we will calculate the middle element from the section based upon this particular result, and then again we will shift the start and end index. So the stopping factor will always be that the start index should be less than or equals to end index. So since the input size is reduced in each of the iteration, you can see we are reducing the input size, right, by half plus start. In that particular case, the log n time complexity is reached. This is it from the time complexity side. If you have any questions or doubt regarding the time complexity, if you want to know how to calculate the time complexity for a particular function, please do let us know in the comment section. We will discuss in upcoming videos. Thank you so much for watching, guys. Please subscribe our channel. Thank you so much.